Okay, so yesterday we were investigating the limits of functions. And I said we want to understand what it actually means about limit of functions. And we said the limit of a function is just investigating the value of the function around a particular point or a particular value of x. So yesterday the function that we had, which was g of x, is equal to, let's go to that function, x squared minus 2 over x plus 2. We wanted to investigate the value of the function around x is equal to -2. And we plug in certain values, -2.1, -2.01, -2.001, -2.0001 into the function. And when you compare these values that we pick on the number line, we can see that all those numbers are on the left side of -2 on the number line. And I said today, we are going to investigate the behavior of the function of values near -2 on the right-hand side of -2. So let's start. I hope today you all have your calculators, so you are all going to contribute. So I will be mentioning your names to perform certain calculations. So we have -2 here, and this is our number line. Some values that are on the left-hand side, sorry, right-hand side of the of -2 include -1.9, -1.99. We want numbers very close to the -2. 1.999, -1.9999. Let's use only these four numbers. And the function is g of x is equal to x squared minus 2 over x plus 2. So we'll pick the first one, g of -1.9. So it will be -1.9 squared minus 2 over -1.9 plus 2. So use the calculator, punch this on the calculator, and then tell me the answer. Then go to 0.99. So it will be -1.99 all squared minus 2 over -1.99 plus 2. Then the last one, no, the third one rather. So g of -1.999, it will be -1.999 squared minus 2 all over -1.999 plus 2. So use the calculator for the values. I'm giving you 5 minutes. Okay, I believe all of you are done, so I'll be calling one after the other to give you the answers randomly. Some hands are up. Okay, let me deal with those whose hands are up first. Kobe, the first one, what did you get?
Sir, please, the first one I had negative 56.1.
Negative 56.1. Any other with a different answer apart from negative 56.1? Anyone with a different answer? Okay, let's go to the second one. I'll comment on that. Texan Aisa, the second one.
At 196.01.
196.001.
Yes,
Any
please.
other, any person with a different answer for the second one? David, do you have a different answer?
No, please.
The same answer.
Yes, sir.
Okay. Osla, give me the answer for the third one.
Sir, please, I had 1,996.001.
1,196.
996.
1,996.001.
001.
Okay. Good.
Sir,
Yes.
sir, please, the first one.
Okay.
I had 16.1.
So we have another version for the second one.
The first one. Yeah.
First one, 16.1.
1. Yes, sir.
Okay. So we all do it together and confirm these answers. So let's learn how to use the ES calculator to perform some of these calculations. Good. So the first one is, so create your fraction by pressing here, open brackets, you type negative 1.9, close the brackets, then you square it by pressing here, then -2, navigate down, then you come and type negative 1.9, then +2. Press the equal to, then you press here to get the decimal equivalent. So you can see that the 16.1 is the correct answer. The 16.1 is the correct answer. So the one who gave the negative 5.6, sorry, negative 56.1, cross-check your computation, your input. Good. Now, let's go to the second one. If you want to do the second one, instead of pressing AC to clear everything, you can edit what you have by using the navigation key. So when I navigate, I can navigate here and just add another 9, navigate up. Now using the navigation, add another 9, then press equal to for the new value. The decimal equivalent is 196.01, and that is exactly what was provided. We edit again, add another 9, so that you become 0.999, and then navigate to the top and do the same, enter, and then it is 1,996.001. So these answers are correct, except the first one, which was wrong. So let's go back to our board. So we are picking this. This is correct. This is also correct. Good. Now, we will not work on the negative 1.9999, but I want to ask you, if we should work, is the answer going to be lesser than these answers that we have, or is it going to be bigger? Yes, David.
Please, sir. I think bigger.
Good. It's going to be bigger because you can see the pattern. And you can also see that negative 1.9, negative 1.99, negative 1.999, negative 1.99999. Which one is closer to the negative 2? These four numbers here. Abrefi, these four numbers here, which one is closer to the negative 2? Abrefi, unmute yourself and talk.
So I think negative 1.9999.
Good. So the last one here is more closer to the what we is also getting bigger and bigger and bigger and bigger. So in mathematics, we say that as we get closer, as our x value get closer to the negative 2, the function g of x also get bigger, bigger, to the extent that it also grows up to what? Negative infinity. I don't want us to waste time like we have done it. You see that the numbers will be getting bigger and bigger and bigger. Anytime we add another point, another decimal place, 9, it will be getting bigger and bigger and bigger. At your free time, you can try it. The 0.9999, then you can do another one, 0.999999, 5 nines. You can try another one with 6 nines. And all of them, the more you are increasing the nines, the more you are getting closer to the negative 2. And the more the results of your calculation is also getting bigger. So we say that as we are at the values of x that we are choosing are getting close to the negative 2, the results of our function g of x is also getting closer to what? Positive infinity. Good. So in limit, when we investigate the left side, as we are getting closer to the negative 2 from the left side, and then as we are getting closer to negative 2 from the right side, if all of them are not pointing to the same number, we say that the limit does not exist. So this limit, the limit that we're investigating does not exist. So the limit does not exist. We'll do another one and you understand. This time around, we'll investigate a limit that exists. Let's pick the function f of x is equal to 2x plus 3. We want to investigate the limits of this function, the limit of this function as, so this is how it is written in the notation, the limits of 2x plus 3 as the x get closer to 0. So this is the notation, take note of it. So when you see this, this is how it is read. Limit of 2x plus 3 as x approaches 0. So on our number line, we know 0 is always on the middle. So we are going to investigate the left side direction as we are moving towards 0 from the left side. So we'll pick certain numbers like negative 0.1, negative 0.01, negative 0.001, negative 0.0001. And then, which of them is closer to the 0? I have selected 4 numbers. Which one is more closer to the 0?
The last one.
The last one. Very good. So the way I've arranged them in such a way that we are gradually moving from negative 0.1 gradually towards the 0. We want to see the behavior. So this is the left-hand side. The left-hand side. So let's perform this calculation. So we are going to look for f of negative 0.1. So that will be 2 multiply negative 0.1 plus 3. Start using your calculators. Negative 0.01. This will be 2 into bracket. Negative 0.01 plus 3. Then f of negative 0.001. 2 multiply negative 0.001 plus 3. Then the last one, negative 0.0001. And this will be 2 multiplying negative 0.001 plus 3. So I'm waiting for the answers. So do this and write the answers down in your exercise book so that when I randomly call you, you just tell me what you got. All these for computation. This time around, I'll not call anyone whose hand is up. I want everybody to speak. So I'll glance through the list myself. So there's no need raising up your hand. I'll glance through the list and then mention your name. So you just use calculator, punch. I ask you to always have an exercise book, a pen, and a calculator. So copy this, use your calculator to get the answers for these numbers. As I mentioned your name, you provide me the answers. If I didn't hear from you, that will mean that you have just connected and you've left the phone and you are roaming. Or notify your parents that you are not paying attention in class. Okay, I know by now you are done. So let me start. Yeah, Jima. Yeah, Jima, the first one. What did you get?
Sir, please, I got 2.8.
2.8. Okay. I'll comment about whether it is correct or not later on. But let me go to the second question. Susan Annan. Susan Annan.
I'm still working on it.
Okay. I hope you have a calculator.
Yes, please. I just took it.
Okay. Then let's go to Owushinshira. Owushinshira.
Sir, please, I got, for the second one, I got 2.98.
2.98. Are you in a car?
Sir, please, I said I got.
Okay, so let's go to the third one. Thank you, Mishira Usu. Paris.
Okay, sir.
Paris.
Sir, please, I got 2.998.
2.998. Then the last one. Reginald Mensah.
Sir, please, I got 2.9998 for the fourth one.
Okay. Good. So let's pause here, but let me confirm the answers so that I'm sure the answers are correct before we move on. So the first one is 2 multiplying negative 0.1 plus 3. 2.8 is correct. Let's go to the second one. 2.98 is also correct. Let's go to the third one. 2.998 is correct. Let's go to the last one. And that is also 2.9998. So they are all correct. Good. I think some hands are up. Let me listen to them before we proceed. Harriet Usu Boateng, your hand is up. Let me listen to you. Harriet, Harry. Okay, Ivy Kodia.
Sir,
Yes, we are listening to you.
the 0.1, it started from the tip of the number line to the 0 at the left-hand side. Did it start from that place?
I don't get your question clearly.
The 0.1. The 0.1.
Negative 0.1.
Yeah. Did it start
Uh-huh.
from the tip side of the number line to the 0?
If you want to plot it on the number line, is that what you mean?
Yes. Yes.
Good. If you want to plot it on the number line, then if we have 0 here and negative 0.1 is here, then the remaining ones will be in between here. Those numbers. Good. When it comes to decimal fractions, the way you compare decimal fractions is different from the way you compare ordinary numbers. For example, if I have 2.13, then I have 2.09. In decimal fractions, when you are comparing in terms of modulus, you, after the point, you start comparing the digit one after the other. So if you have 1 here and then there's 0 here, even though here is 9, we consider this number as bigger than this one. Okay. But remember, the numbers are provided: negative 0.1, negative 0.01, negative 0.001. On the number line, when I have 0 here, in terms of magnitude, the numbers increase in this direction. That is why you have negative 1 here, but you have negative 2 here, and then you have negative 3 here in that order. In terms of modulus, in terms of magnitude, the increasing is towards this direction. So had it not been that the fact that this is negative numbers and we erase the negative numbers, this would have been bigger. This number would have been bigger than all of them. Would have been bigger than all of them. So if I want to place these numbers on a number line, and if they are all negative, then the 0.001 should come first, followed by 0.01, then followed by the 0.1. I'll get it. And that's why we say this one is more closer to the 0 than the rest.
Thank you.
Are you okay? Yeah.
Yes.
Good. So we are done with the left-hand side of the 0. Now let's look at the right-hand side. Right-hand side. Right-hand side. The right-hand side of 0, numbers that are very close to 0 at the right-hand side of 0 include positive 0.1, positive 0.01. Let me write them from the smallest. You can have Okay, the arrangement is okay. Positive 0.1, positive 0.01, positive 0.001, positive 0.0001. These are numbers that are closer to 0, but they'll be at the right-hand side of 0 because they are positive numbers. They'll be at the right-hand side of 0. Good. Which of these numbers is closer to 0? Yeah, David.
0.0001. 0001.
Okay, good. So now let's investigate the behavior of these numbers too. Now they are positive. So, and the function is f of x is equal to 2x plus 3. So we'll start with the first one, f of 0.1, and that will be 2 multiplying 0.1 plus 3. F of 0.001, sorry, 1001, that is 2.02 times 0.01 plus 3. Then f of 0.001 is equal to 2 into bracket 0.001 plus 3. And the last one, f of 0.0001 is 2 multiplying 0.0001 plus 3. Okay, 2 minutes. All of you should try. I'll call you randomly. Randomly. Don't raise up your hand if you are done. Randomly. So let me set the timer on. After 2 minutes, so I'll start the timer. This one is just calculator work, so I'm not expecting you to use more time. We have about 40 seconds. I said, don't raise up your hand. I'll call you randomly. I want everybody to take part. Yeah, it's time. Okay, so randomly, Abdul Aziz, what did you get for the first one?
Please, I don't have a calculus, so I'm on it.
Why?
Before I'd come home, they stole my calculus.
Oh, sorry for that. Try as much as possible to get a calculator.
Okay.
Mm-hmm.
Okay, then.
Okay.
Thank you.
Okay. Good. So let me call another person. Afajina Yevignon. If I have not got your name correct, forgive me. Afazina. The first one. Unmute yourself and speak.
Sir, please, the first one.
Yep.
3.2.
3.2. Okay. Let's go to Bella. Bella, the second one. Bella.
Sir, please, 3.02.
3.02. Let's go to Chief Kopo. The third one. Chief Kopo. Chief. Chief have left the meeting. Davina. Davina. Or is it Davina? Colleen. Davina, Colleen. It means you're also not paying attention. We have to let your name down and inform your parents. Erica Biu.
Okay, so I got 3.002 for the third one.
3.002. And the last one, let me call Joyce Sewa. Joyce Sewa. Joyce Sewa, unmute yourself and speak if you can hear me. If you don't speak, it means that you're also not paying attention in class. Let me go to Kwajo Mensah. Kwajo Mensah.
Sir,
Yes. The last one. What did you get from your calculator?
I got
Kwajo, I can't hear you. Is it your network? Mirabel. Mirabel.
Sir, please, I got 3.0002.
Good. All these answers are correct. Now, let's come back to the first one that we did. Okay, I saw some people whose hands were up. Let me listen to them whether it was a question they wanted to ask or I think they have lowered down their hands. Okay. Good. So let's come to this side. You see, I've arranged the numbers in such a way that the values are greater and are getting closer to 0.0. They're getting closer to 0. What can you speak about the output? It was 2.8, 2.98, 2.998, 2.99998. Can you say that these values are getting closer to a particular whole number? And if it is, which whole number is that? The first output was 2.8, 2.98, 2.998, 2.99998. Yes, David.
Sorry.
David, yes. Come again.
3 say.
Yeah, 3 is correct. 3 is correct. You can see that the numbers are getting so, unlike the first one, where the first function, where you see that the numbers become so huge so quickly, almost getting to infinity. This one is not like that. You see, they are growing steadily towards a particular number. And that number is what? 3. For example, the last one, if you decide to round it to maybe 2 decimal place, you'll get 3. Good. Now, let's look at the other side. This is the values on the left-hand side of 0. Let's look at the values on the right-hand side of 0. From 0.1, we move a little bit closer. 0.01, move a little bit closer. 0.001, then we move more closer, 0.0001. And look at the answers that we obtain. What conclusion can you also draw here? Abrefi, your hand is up. Okay, that's the wrong hand. What conclusion can you draw? Yes, Ivy Pineboa. Korea. Kodia, I'm ready for you. Okay, let's go to Reginald Manson. Maybe Kodia is having some challenges. Reginald.
Yes, sir. So for this function, the values are also getting closer to 3.
Good. You can see that the values are also gradually moving towards 3. 3.2 became 3.02, became 3.002, became 3.0002. The next one, who can even predict the next one? Yes, the next one. Who can predict the next one? Yes, Anthony Ajikum. Anthony Ajikum.
Sir, please, 3.
Yes, go on.
3.00002.
Correct. So you can see that the right-hand side too is moving towards 3. The values are all moving towards 3. For example, the last number here, if we decide to round to two decimal place, and that is just 3. That is just 3. So when the left-hand side and the right-hand side all point to a particular number, we say the limit exists, and the limit is that particular value. So for this function, we can conclude that the limit exists. So the limit of the function 2x plus 3 as x approaches 0, the answer is 3. The function in both directions approaches 3 when we did our investigation. Good. Now, we have done the fundamental the rubrics, the idea behind limits. But when we are doing computation about limits, we will not be using this investigating. There are certain principles that we can follow and then find the limit of functions algebraically. Algebra means you just calculate. You don't need to pick certain numbers that are closer to the point in concern and then start investigating the behavior of the function. I just want you to understand the background, what it means when you say limit of a function. Limit of a function. So far as your curriculum is concerned, that is how it is. Everything that we do, we should understand it and know the why and the how behind it. Not just coming to tell you that, oh, when you see a question like this, do it like this. No. I hope you are okay. So I'll pause for just 1 minute if you have any question before we continue. Okay, so let's proceed. So if there's no question for me, then now we are going to evaluation of limits. Evaluation of limits. Mhm. So let's pick our very first question. We are to evaluate the limit of 3x squared minus 5x plus 1 as x approaches 2. As x approaches 2. Good. In every limit, you must try what is known as direct substitution first. Direct substitution. If the direct substitution works, fine enough. That is all. But if it doesn't work, then you move to the next stage, the next level. We have different stages. So now I will give you functions where it will deal with direct substitution. Sometimes direct substitution will not work. Then you have to move to the next level. But always the first step is to do direct substitution. And what does it mean by direct substitution? We are given the limit to find the limit of 3x squared minus 5x plus 1 as x approaches 2. When you say direct substitution, it means that the 2 should just be substituted into the function. Like that. So this should be 3 raised to the power 3 times 4, 2 raised to the power 2 is 4. And this will give us minus 10. And this plus 1. And then this will give us 12 minus 10 plus 1. 10 minus 12, 12 minus 10 is 2 plus 1 will give us 3. So this, we're able to evaluate this by using the direct substitution approach. There are some of them, especially rational functions. Direct substitution will not work. For example, if you have x minus 3 all over x plus 1, and we are looking for the limit of the function as x approaches -1. If we do direct substitution, we are going to have -1 minus 3 over -1 plus 1. The denominator will tend to become 0. And whatever number you get at the numerator, you can't divide it by 0. So direct substitution will not work. So such functions, we have a way, or in such situations, we have a way of handling it. So we'll do that. But now, let's do direct substitution for the meantime. Okay? Good. Let's go to the next question. That one, all of you will evaluate it. I'll give you only 1 minute to do that. And I'll randomly call you to give me your answer. The limit of the square root of x plus 7 as x approaches 9. So start work. 1 minute. Okay, let me make it 1 minute, 30 seconds. Hello? Yes, it's time. So, Liz Danso, what did you get?
4.
4. Okay, can you walk us through your solution?
Sure.
Okay.
First I substituted the 9 to
Yeah.
the x. So
Okay.
I got roots. Root
Mhm.
9 plus 7
Mm-hmm.
is equal to root 16. And root
Okay.
16 is equal to 4.
Good. That is correct. Perfectly. Let's look at another one. And I think it's about 8 minutes. So then I think after that one we'll close. So the limit of the freshman x squared plus 4x minus 1 as x approaches 3. Hello? I hope you are done by now. Adu Oseng Kruma, what answer did you get? And you walk us through your solution. Adu
Sir, please,
Oseng.
Sir, please, the first one I'm done with.
Okay, so you're not done with the second one. Okay. Then let's go to another person. Amadou.
Sir, please, I'm almost done.
Why you guys don't have calculator or what? Because some of these things you don't need to.
Sir, please, I got 20.
I got 20. Sir, please, I got 20.
Amadou, okay. Amadou, walk us through your solution.
So I was using the direct substitution. So I'll
Yes.
fix 3 wherever I see x.
Okay.
And the equation is x squared plus 4x minus 1. So
Correct.
that would be 3 to the power 2 plus 4 multiplying 3 minus 1.
Okay.
3 squared is 9.
Mm-hmm.
4 times 3 is 12.
Mm-hmm.
1 minus 1. And according to board maths, addition comes first. And 9 plus 12 is 21.
Okay.
21 minus 1 will give you 20.
Exactly. Exactly. Any question? Any question on what we have done so far?
No, sir.
Yes, sir.
You have a question?
Sir, please, my network wasn't stable, so I didn't get some of the things. And I had a question. If you're able to answer, maybe I'll get this one. I was asking if the limit is all about the function being undefined.
It's not about the function on being undefined. We say the limit of a function is investigating the behavior of the function around the given point. Around the given point. So that's a practical demonstration we're doing from yesterday. Good. Now, we have moved from that practical evaluation that we were doing. Now we have moved to a stage where we want to evaluate limit by not using picking the numbers around the point, but want to do it algebraically. And there are so many ways of doing that at different levels. The first level is always to do direct substitution. So when the function is given, we just input the limit value into the function and evaluate. That is the basic form of finding limits. There are certain situations when you do a direct substitution, it won't work. Then it will take you to the next stage or next level of computation that I will teach you tomorrow. Okay? Are you okay?
Yes, sir.
Okay, another question?
No, sir.
Okay, if that is the case, then
Yes,
we'll end now. But before then, let me paste some questions, take a snapshot, and then you practice them before we meet next week. So there are only 3 questions.
Sir, please, I can't see.
Can you still not see? Is my screen not showing?
Sir, I can see. It's clear now.
Okay. Let me give you attendance words for today. So you can take a screenshot of the questions as I prepared attendance word.
Sir, please, I can't see your screen.
Then quickly exit and then join. It might be from your network. So the attendance work is virtual. Virtual. Let me paste it here for you to see. Virtual. That is what's on the screen down there.
Sir, please, the attendance was where?
Can you see my screen?
Yes, please. Now that I can see it.
Okay. So thank you very much for joining.
Okay.